So this class is AI 5 to 8. So it's digital control systems. Um, I want you guys to, the class has started already. So in case I'm saying something and you need clarification on anything I'm saying, then you just post in the chat, then I would go back and explain. So I hope you all understand that. So as I was saying, this class is AI 5 to 8, digital control systems. So the class is basically, so if you've gone through the notes on module, you would discover in the first lecture, which is week 1. I told you that in that week 1, I said that this class is just basically the control systems you guys did in 412. So in 412, you did control systems. So control systems was, that course was basically, you were analyzing control systems in you were analyzing control systems. Sorry, please, just give me a minute. Okay, sorry for that. So basically, I told you that the course is basically the control systems you guys did in 412. But in 412, it was, you were analyzing systems in the continuous domain. So basically, you were analyzing systems in the continuous domain. So all you guys did in 412 was in continuous domain. But in this course, we are dealing with discrete, in the discrete time domain. We are not going to be focusing on the continuous time domain. So that's basically the difference between 412. Sorry, I'm going to mute all of you guys now so that there will not be distractions. Okay, so as I was saying, so this course is basically, you'll be analyzing systems in the discrete time domain. So that's what we're going to basically doing. So all the concepts you learned in control systems in 412, all the concepts will apply for this course. So that's the introduction. Then for the week 2, we did basically computers, and we talked about AD and DA converters, so analog to digital and digital to analog converters. So I gave you a quiz. So I saw the submissions. Quite some people have done and submitted the quiz. So when I checked it yesterday, it was up to 95 people that have submitted. So I would expect your submission. So from the submissions, I discovered that a lot of people were following along in the class. They were following the notes. So I'm going to be talking on the Z transforms today. And basically, what's the Z transform? Z transforms is basically, when you were dealing with continuous time, in continuous time domain, that was in your 412, you had to work in Laplace transform. So you had to convert from continuous time domain into Laplace transform, because Laplace transform is actually, when you transform the signal into the Laplace domain, is much easier to work on. It's much easier to work on the signal than when you're just having it in the pure time domain. So basically, in the discrete time, you're not converting it to Laplace transform, but you are converting the discrete time domain into the Z transform. And the reason why we are converting it into the Z transform is because it's much easier to work on. So we can do a lot of complex things when we're in the Z domain. So for this class, I told you that you guys should read the lecture notes. So I'm not going to go over the lecture notes. I'm just going to go over the worked examples. So I posted the worked examples yesterday night, and I will just go over it. And if you have any questions regarding that, you'd let me know, because after this class, I'm going to be posting a quiz based on what we've learned in this class. So it's better for all you guys to pay attention. Then if you have any questions, just type it in the chat, then I'll go over it. So I would share my screen now. So I'm sharing the worked example which I gave you all, which is on your model. So can you all see my screen? So I just want to know if you can see my screen. So if you can see my screen, just um, just let me see it in the chat, so that I'll be sure that you can all see my screen. Okay, all right. So a lot of people said they can see my screen. So I'll just go ahead. So I'm on Z transform definition. So like I told you, in this course, we are considering a discrete time signal. So what's the difference between a discrete time signal and a continuous time signal? For a continuous time signal, the time variable, which is on the x-axis, is a function of time, and time is continuous. So you can have t as a fraction or with decimal numbers. But in discrete time, you are considering your independent variable is an integer, which is k. So, and for the integer variable, we're only going to have that k value as just integer instances. So k can only be from 0, 1, 2, 3, 4, 5. So you can also have negative values. So you can have negative or positive values. But the most important thing is that is an integer, be it positive or negative. But in continuous time, it's just the independent variable. It can be fraction, it can have decimal parts. So that's the difference. So when you have a discrete time signal, x of k, and you want to transform it to the Z domain, so this is the function where my cursor is. So this is the function when you want to transform a discrete time signal into the Z domain. So you are going to sum from k is equal to 0 to infinity. You are going to sum up the value of the function, then you multiply by z raised to power minus k. So for instance, so when you expand out this function, you have x of k0. You have, okay, somebody wants me to zoom in. Okay, so can you see the cursor? Can you see my cursor? Because I'm trying to highlight some things on the screen. Can you see my cursor moving? I need feedback from you guys. Can you guys? Okay, you can see my cursor. Okay. Okay, so I will zoom in Then I will just, like somebody requested. So I guess maybe it's clearer now. So this definition of Z transform, you are summing from k is equal to 0 to infinity. So basically you have this x of k function. Since you are summing from k is equal to 0 to infinity, so this, the first term that I'm highlighting is when k is equal to 0. So this second term is when k is equal to 1. So when k is equal to 1, you simply substitute 1 into this, and you substitute 1 into this. And remember, you are summing. So that's where this summation comes from. Then, so that's where this summation comes from. So when k is equal to 2, so you just substitute k into this. Then you add it. So this is when k is equal to 3. So you have this term when k is equal to 3. So this becomes 3 and this becomes 3. Then is a summation. So you have this dot, dot, dot. So you can actually sum. So the definition of a Z transform is that you can sum, you will sum the signal using this function from 0 to infinity. So that's basically the Z transform definition. So you sum the signal from 0 to infinity. So do you all understand this explanation, this particular line I've said? So I need feedback from you guys. If you have any questions, please just post it in the chat. If you don't understand, then I would go over it. So basically, let me just go over it once more. Let me go over it once more. This is your, for Z transform, you are converting from the discrete time domain into the Z domain. And when we started, I told you the reason why we are doing that. And I said that the reason why we are doing that is because when we are in the Z domain, it's much more easier to manipulate the signal than when we are just in the time domain. So we want to be able to convert the signal into the Z domain so that we can do lots of complex analysis on the signal. Like we can study its stability, we can just study a lot of things. We can do a lot of things when we're in the Z domain. But when you are limited to the time domain for a discrete time signal, you cannot really do much and you cannot really see much. So that's the reason why we have to convert to the Z domain. So all our analysis in this course is going to be on the Z domain. So I would have just told you guys to read the lecture note, but because this is the foundation of the course, if you guys don't understand Z domain, then because the foundation of this course is Z domain. The foundation of this course is Z domain. So if you guys don't understand Z domain, then you cannot do anything. So that's why I actually arranged for this meeting so as to give a full explanation of this. So the first example is you should find the Z transform of a unit step signal. So what's a unit step signal? A unit step signal is simply a signal that when for k is less than 0 is 0, but for k greater than 0 is 1. So it's just like a constant signal. It's just 1. That's from k is equal to 0 to infinity. It is 1. But for k less than 0, it is 0. So that's a unit step signal. Then when you want to transform it to Z domain, you can see this is the definition. So this is the definition of the Z transform. So instead of x of k, I just put u of k there. Then you would know that, so for this part, we just simply expanded out this summation. So it sums from 0 to infinity. So that's why we have this dot, dot, dot. So the next one was supposed to be U4 Z minus 4. So that's why you have it here. Then, given the definition of a unit signal, a unit step signal, the value is 0 for k less than 0. So for k less than 0, you don't have any values. But when you start from 0, u of 0 is 1, because for k greater than 0 is 1. So for u of 0 is 1, u of 1 is 1, because a unit step is just 1 throughout from 0 to infinity. So u of 2 is 1, u of 3 is 1, u of 4 is 1, dot, dot, dot. Then you have this summation here. So you have z minus 0, z minus 1, z minus 2, and z minus 4. So basically, this, you are simply expanding this one using the Z transform definition. Then we are putting in the values, because a step signal has a value of 1. A step signal has a value of 1. So U of 0, U of 1, U of 2, U of 3, they are 1, 1, 1, 1, 1. So we have this. Then when you expand this one out, 1 times Z minus 0 is 1. So, 1 times Z minus 0 is 1, yes. Then 1 times Z minus 1 is 1 over Z. So you have it, you continue the series like that. So if you observe this series, you will see that this is a geometric series. So you've all done geometric series when you were in secondary school. So this is a geometric series. And remember that for the Z transform, you are summing from 0 to infinity. So the formula, if you can remember in your secondary school, this is the formula to sum from infinity for a geometric series, to sum from 0 to infinity, where A is the first term, R is the common ratio. So the common ratio in this case is 1 over Z. So that's the common ratio, or Z minus 1. So when you simply put this in the equation, you are going to get this. So you are summing. I'm coming. So you are going to get this. Yes. Then when you multiply both sides by Z, so you multiply the numerator by Z and you multiply the denominator by Z, you are going to get this. So this is the Z transform for a unit step signal. So do everybody get my explanation? So I need you on the chat. I need some feedback on the chat if you all got my explanation. All right, thank you. So unfortunately, Zoom is telling me that my remaining time is 8 minutes. They say I have to upgrade to the pro version so that they can give me the full time. I don't know why that is happening. Is it same on your side? The Zoom, is it allowing you? For me, it's saying that I have to okay. So a lot of people are saying that I should allow the time to expire, then I will book another session. Okay, yeah, it's giving me 40 minutes. Yeah, it's 40 minutes. Yeah, I'm using the free version. That's why. So, okay, somebody says it wants a 5 minutes break. And we can resume another session. Okay. All right. All right. So once this session expires, I will just go on. But once this session expires, I'm going to book another one. Then you guys would all join. So let's just continue. So once it expires, we just leave. So let's go to the second example. So the second example is okay. So let's just move on. Uh, so let's just move on to the second example. So I just have like 6 more minutes. So once this session expires, I will just book another one where we complete it. So the second example is to find the Z transform of a unit ramp signal. Okay, so I have less than six minutes. So I have less than 6 minutes now. So I'm going to end since I have just less than 6 minutes, I will just end this meeting, then I'll book another one. So in the second meeting, I'll just be fast so that we can cover more ground in the next one. So I'm going to be ending the meeting now. Then I'll book another one. So you just go to your module and check for the new link, then you join. Okay. All right.